Hi everyone, I am happy to present our work Noise-to-Noise Flow. My name is Ali Maliki and I have done this work with my collaborators Shayan Kusha, Micah Brown, and Marcus Brubaker, all affiliated with York University and Samsung AI Center, Toronto. To summarize our contributions in this work, we introduce a novel framework under which a noise model can be trained without clean images. Then, we make sure that the model performs on par with its supervised counterpart and outperforms other baselines. Finally, we observe that the denoising performance is boosted compared to training a separate denoiser. Image noise modeling is a long-standing problem in computer vision. Image noise is an unwanted and inevitable corruption added to the image measurement. It is almost impossible to capture a true noise-free image. Conventional noise models such as a simple Gaussian model were the first attempts to model image noise characteristics. More realistic noise models such as noise level function and Poisson Gaussian were also introduced, but they were still far from reality. Recently, NoiseFlow, which is a deep neural network-based noise model, was proposed that uses customized normalizing flow structures to model the complex image noise characteristics, conditioned on clean images and other image properties. It has proved to be effective in capturing complex behaviors of the image noise and outperformed other conventional baselines. However, it relies on access to clean images, which is a major drawback. Estimating the unseen noise-free ground truth images is a hard problem. One popular way of doing so is to take multiple images, aligning and then averaging the result, which is very hard and impossible in certain circumstances, such as dynamic environments. In the denoising domain, this motivation led to the idea of noise-to-noise, where one can train a denoising deep neural network with only pairs of noisy images by taking one as the input and the other as a target. This relaxation makes training a denoiser easier as there is no longer a need for clean image data. Motivated by the same constraint, in our work we propose a new framework under which a noise model can be trained without clean images by jointly training a noise model and a denoiser. We call our model noise-to-noise flow. The two noisy images are given as input to the denoiser, and then flipped to calculate the noise-to-noise loss, which is the L2 distance between an image and the estimated clean image corresponding to the other image. Then, the image noise vector is estimated by subtracting the denoised images from the noisy inputs, and then a noise model such as NoiseFlow is used to compute the negative log likelihood of one estimated noise vector conditioned on the other denoised image. The two different loss terms are then combined into the one final loss given the following formula. The noise modeling and synthesis have been evaluated in negative log likelihood per dimension and KL divergence on the SIDD, which is a standard image noise dataset. We used noisy image pairs from different scene instances to train our models. We compared noise-to-noise flow against conventional noise models such as additive white Gaussian noise, noise level function, and a calibrated Poisson Gaussian, as well as noise flow, the supervised counterpart of our model. Also, in order to verify the advantage of our joint training framework, we included a baseline where we trained a noise-to-noise denoiser followed by a noise flow model. The results indicate that while our model outperforms other baselines significantly, it is on par with NoiseFlow, the supervised counterpart, in both density estimation and noise synthesis, while trained without clean images. Additionally, the comparison between our model and training a noise-to-noise and NoiseFlow model separately shows the value of our joint training framework. In this slide, we can see some visual noise samples generated from our model for clean patches in the SIDD compared to other baselines. Our model also trains a denoiser as a side product, which has been evaluated in PSNR and SSIM against a supervised DNCNN baseline trained on noisy clean image pairs, as well as a denoiser trained with only noise-to-noise. The results show that the denoiser in our model improves over noise-to-noise, indicating that the joint training has also a positive impact on the denoising performance. Thank you for your attention. For more information, please stop by our poster and visit our website.